We are still on using trigonometrical ratios and solving right angle triangles. Next, we are looking at some angles known as special angles, and we are to obtain the trig ratios of these special angles in fractional form. These angles are 0 degrees, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now, without much ado, we all know that sine 0 is 0. And since 90 is complementary to 0, cos 90 will also be equal to 0. That's it. And then next we look at 90. Sine 90 we know is 1. And since 0 is complementary to 90, cos 0 will be 1. Tan, we know, is the ratio of sine to cos. So tan 0 with sine 0 over cos 0. So I can call that 0 all over 1. Since sine 0 is 0 and cos 0 is 1. So that gives me 0 over 1, which is 0. And tan 90 will be what? Sine 90, which is 1, divided by cos 90, which is 0. Here we have a fraction with the denominator as 0. Such a fraction becomes so large, so we say it is undefined. Let's look at how to obtain values for 30 and 60. For these two angles, we're going to make use of an equilateral triangle. An equilateral triangle we know has all angles and all sides equal. Here we have a triangle where the sides have been given a value of 2, and of course the angles automatically must be 60 degrees. We need to create 30, angle 30, by drawing a perpendicular from C. Let me change the color of this pen. Down to the side AB. We can call this AD. And then we'll try to find the length. Here we have a right angle triangle here, CDB. So we try to find the length of this side. Let's call it Y. So that's it there. That's a perpendicular. How have you obtained this root 3? Let's quickly look at how to get the root 3. If we look at the right angle triangle here, this is Y. 2 is the hypotenuse. And we're looking for this Y. So we agreed that 2 square will be equal to AD square plus DB square. AD, is it AD? Yeah, AD. That's Y, the unknown side, plus DB, which is 1 square, and then this is 4. So we have 4 minus 1 is equals to Y square, which gives us 3 equals to Y square. Taking the square root of both sides, we have Y equals to root of 3. And that's how we came about the value of AD there as root of 3. Now with that, we can set out. First, we look at angle 30. If we are considering angle 30 there, looking at angle 30 here, then the side DB will be facing angle 30, so we can call the side DB the opposite side. Of course, you will agree that side AB is the hypotenuse, always the hypotenuse because it's facing the right angle. And then the side AD, which is our root 3, is going to be the adjacent side. So sine 30 is opposite over hypotenuse. That's 1 over 2. Sine 30 will be 1 all over 2. Cos 30 will be what? Will be adjacent root 3 all over hypotenuse root 2. So that's root 3, the adjacent all over 2. That's root 3 over 2 there for the cos. And then the tan will be what? Opposite, which is 1 all over what? Adjacent, which is root 3. And that's it for 30. Sine 30 is 1 over 2. Cos 30 is root 3 over 2. tan 30 is 1 all over root 3. How about 60? For 60, we change our orientation. We are now looking at angle 60. Which side will be the opposite? Sorry, let me change the marker. Now I'm now looking at this as my considered angle. So root 3 as this AD becomes the opposite side. Root 2 remains the hypotenuse, it is facing the right angle, and DB is now the adjacent side. So there's a change of rules there. Now cos sine 60 first. Sine 60 will be opposite, which is 1, that's DB. Sorry, root 3, that's AD, is the opposite. All divided by what? 2, the hypotenuse. Cos 60 is adjacent, which is 1, as you can see there, all over what? 2, the hypotenuse. And tan 60 is what? Opposite, which is the root 3 itself, divided by adjacent, which is 1. So that's sine 60, that's cos 60, and that is tan 60. Now we have trig ratios for 30 and 60 in fractional form. What about 45? For 45, we make use of an isosceles right angle triangle, where the two sides that are equal are given the values of 1. Then we need to find the value for the hypotenuse side, which right now we can see is root 2. How did we obtain root 2? Let's call this x. If we apply Pythagoras theorem, this will be x squared equal to 1 square plus 1 square, where x is the hypotenuse and then the other two sides are 1 and 1. You agree this is 2. So x squared is 2 and my x is therefore square root of 2. So that's how we obtain root 2 there. That's how the value root 2 is obtained. So if we are looking for sine, so let's take any of the angles. This is 45 degrees. Let's use that one. Then this will be my opposite. Of course, we know the hypotenuse is always the one facing the right angle. And then this will be the adjacent. Sine 45 will be opposite over hypotenuse. Opposite is 1. Hypotenuse is root 2. So I have 1. Sorry, let me change the color of the marker. That will be 1 divided by root of 2. That's sine 45. Cos 45 will be 1 all over root 2 also. Why? Because that's adjacent, giving us the value of 1. And then the hypotenuse is root 2. Tan 45 is opposite is 1. Adjacent is 1. So 1 over 1. That will give us that. So let's type this out. That's sine 45, 1 over root 2. Cos 45, 1 over root 2. And tan 45 is 1. So that's how to get the trig ratios of these special angles in fractional form. But how can I remember this in the case of an examination? Let's go through it very fast. Without these diagrams anymore, no triangle. Let's see how I can remember this. There are certain trig ratios we know by heart. We know that sine 0 is 0. And we know that sine 90 is 1. With this, I can get cos 0. Knowing that cos 0 is the same thing as sine 90. Why? Because 0 and 90 are complementary. Therefore, the cos of 0 will be equal to the sine of what? 90. So that gives me 1 there. And then the cos of 90 must be equal to what? Must be equal to the sine of 0. And we know the sine of 0 is 0. So therefore, cos 90 is equal to 0. Sorry. Then how about the tan of 0? Well, I don't have a diagram here, but I know that tan is the ratio of sine to cos. So tan 0 must be equal to sine 0 over cos 0. Likewise, tan 90 must be equal to sine of 90 divided by cos of 90. So tan of 0, tan 0 is sine 0, which is 0, all over cos 0, which is 1. Of course, 0 over 1 we know will give us 0. How about tan 90? Tan 90 will be what? 1. That's sine 90 divided by 0. Now 1 over 0 is undefined. So that is undefined. So straightforward. Next, I look at 30 and 60. It is generally known that sine 30 is 1 over 2 at 0.5. I look at what's the complement of 30. That's 60. Oh, cos of 60 must be 1 over 2. Now, root 3 over 2 is a very popular value. So I put it there for sine 60. And I also put it there for cos 30 because 30 and 60 are complementary. That's the only thing I need to memorize. And again, I know the ratio of sine to cos will give me tan. So to get my tan 30, I simply divide sine 30 by cos 30. 1 over 2 divided by root 1 over 2 divided by root 3 over 2. 1 over 2 divided by root 3 over 2 will give me 1 over 2 times 2 all over root of 3. This cancels this, and that gives me 1 over root 3. For tan 60, the reverse is the case here, so I'm going to get straight away root 3. Now, sine 45 and cos 45 are equal. So tan 45 will be 1 because tan of 45 is sine 45 over cos 45. This we have to find a way to memorize. It is 1 all over root 2, and then this is 1 all over root 2. Practice this severally and you get used to it. We'll make use of this in subsequent videos.